Up guys, day 97 on 100 Days of LeetCode. We got an easy problem. It's another binary search problem. I've done a few of these, and we're going to do another one. Let's do it. So, number 35, search insert position. So we're given a sorted array of distinct integers and a target value. We want to return the index if the target is found. If not, we want to return the index where it would be if it were inserted in order. You must write an algo with O log n runtime complexity. So with any sort of searching situation, if you see O log n, you think binary search. So that's, perfect. So we have this nums, we're looking for the target of 5, and of course we find it at index 2. Okay, that's why we output it. Now if the target is 2, well, we would insert it at index 1, right? Because it would be between the 1 and the 3, we would insert the 2 at index 1, everything else would get pushed back in index. Now, example 3, target is equal to 7, so it would be over here, right? Index 4. Right now we only have 4 numbers, 0 through 3 are the indices, and then we would just put it over here, so we return 4. So we're just going to implement binary search. There's a little bit of a twist at the end, which I'll explain, but let's do it. So we're going to say low is equal to 0, high is equal to the length of nums minus 1, and when I mention binary search in my videos, I usually don't go too in depth because they're usually used. It's usually used as sort of just a smaller part of the solution, but here it's primarily a binary search solution, so I'll explain it. Essentially what we're doing is, because we have a sorted list, we can basically take the midpoint of whatever we're searching, and we can see whether or not that is equal to our target, right? So if we have this list, we can basically check the number at the midpoint, and the reason why we can do that is because it's sorted. So right now, for this list, we would set our low to 0, right? And our high would be set to 3 because we want to get the last index. So in this loop, while low is less than or equal to high, we are going to create a mid, and we're going to set that equal to low plus high minus low integer divided by 2. So in this situation, what this is doing is it's giving us our low, which is 0, plus high minus low, 3 minus 0 is 3, integer divided by 2. 3 integer divided by 2 is 1. So we would search the first index. And of course, the reason why we're using integer division is because we can't have a float as an index. So we need to just take, the integer division, right? So we would have index 1 as our mid, and what happens is we're going to check that against our target. And because it's sorted, if this is less than our target, right, which in this case it is, then we're going to update our low value. And then we're going to do this again and have a new midpoint, which we can then check again. So, let's write the code for that. So we're going to say if nums mid is equal to target. Okay, so this would be the case if we found it, right? If we, at this index, have a number that is equal to our target, that means we found it, so we can just return mid. That's the index that we're looking for. Now, like I said, if nums mid is less than our target, right, which would be, going back to the example that I was talking about, 3 is less than our target 5, we're going to increase our low. So we can say low plus equal to 1. And then the else block here, which, just to have it be obvious, I'll just write what it actually is. If nums mid greater than target, then we are decrementing our high, right? Because we want to search basically all the elements on the lower side of the mid index. So yeah, now we're through this loop, but there still is the case where the target isn't in the list and we want to find out the insert position. Well, it turns out we can just return low. And the reason why we can return low is because if we get through this whole list and do not find our target, which would actually be this example, we're going to be faced with one of these comparisons as basically the last operation in, or the last two operations in this actual loop. So if the number at mid is less than our target, well, we're going to increase our low, and we're going to have the correct low anyway, because we can just, we now have the index that we're going to insert it, right? But if our num's mid is greater than target, right, well, we're going to decrement our high, but the current low that we have would be the number, the index that we have to insert it at anyway, because it would be sort of one step over from a number that is less than that number. Okay, so that's why we can just return low. And let's just submit this code. And there we go. That's how you solve that problem. That was day 97. Guys, we got 3 days left. We're almost done. If you enjoyed those videos, please like, subscribe. We'll see you tomorrow. Take care.